Good morning, everybody. Thank you for attending. My name is Hisham, PhD student, and we will talk right now about AI for customer support. How can we use artificial intelligence to support customer support at any company and so on? So,
I'll just click on it. Who else is in the room? Lots of people.
why it's not working?
You won't click back onto the presentation.
Yeah, you might need to click with the mouse back on the PDF.
Okay, so main research goals of my PhD. I focused at 3 points exactly. How can I make customer churn analysis, customer churn? How can I make the company predict who and which client can leave and would leave their service? Also, how can we adjust firm customer clustering? How can we apply clustering at the firm and firm customers so they can predict and can go and can put each type of customer at specific group since they can treat them as a suitable way. But today's talk and today's point, it's how can we make analysis to social platforms data. As we know that this century and this decades, we have this invasion of social media platforms everywhere. So we have a huge amount of data, tweets, text, pictures, reviews, points of view everywhere. And the smart person who can scrap and download everything and can analyze it and can extract information about it. This project, it used data from British Telecom in collaboration with David Yearlings, Cyril Caldas, and Michael Frey from BT Research, and we make collaboration meeting with them each 2 weeks. So how we started to make data scribing techniques? Actually, why we should make data scribing? Data scribing, as we just said, we have a fortune. We have a huge amount of data everywhere. And we don't need to make surveys. We are not at like 20th century anymore. We don't need to make surveys. We don't need to call people. We don't need to ask them for their opinions because their opinions indeed, it exists. We just need to know how can we get it? How can we analyze it? How can we make text processing for it? So data scribing to just get full customers analysis, depending on their opinions, reviews, and complaints. But of course, we need to make data clean to everything we need. Because their opinions, reviews, questions, it's not pure at just website. Sometimes we need to remove any unrelated text, any unrelated things here or there. And sometimes while making data scribing, it just mixed with programming language like Java, HTML, or something, or XML. And anybody who just worked with XML language, he knows that it's like a headache to just get and filter just needed text for it. So we scraped data from 5 sources so far: Twitter, Trustpilot, Facebook, BT Forums, and Quora. We just downloaded and scrapped hundreds and thousands of tweets, comments, posts, questions, points of view, and we applied all data cleaning for them. So once we download the data, we need to have like a quick insight, like a quick checking for this data. So for example, if we downloaded hundreds or thousands of tweets or comments or something about customers of BT, so we need to know what they're talking about. Do we need to read every comment? Do we need to check everything? No. We have this tool, which is called Word Cloud. Word Cloud, it represents all text, something like this. It just counts which word it's repeated more and represented at a specific size, which depends on its repetition time. So for example, these tweets or these words, it's just from tweets, which is downloaded from Twitter at 2020 and 2021. All these tweets are just with hashtag British Telecom. So we can see that these words and this word, BT, now, one, well, we can see it's repeated more than other words. But when we have this checking, we can see that yes, there is word think or sky or hi or new or today or game. So we can have some insights about what they are talking about. For example, if we see a word horrible, very big, or if we see the word thank you, very big, so we can know what they are talking about. Of course, word cloud, it's not enough to know everything about it, but it's a very important tool so we can have a quick insight about it. For example, at the left, we can see tweets containing games keyword for BT data. So we can see words like game, BT, today, good, time, day, thanks, sky, team, and so on. So we can know what's the trend of customers. While at the right figure, we can see the headlines of some reviews at Trustpilot website. So we can see the word worst, terrible, poor, bad, wow. So we can know exactly what they are talking about. Again, it's not an accurate tool to know everything about it. We have at natural language processing, we have more deep and accurate tools to know exactly what they are talking about. But we can know quickly how they think, what's the topics they are thinking about, and so on. So after we downloaded everything, after we downloaded data, we move to what's called topic modeling. Topic modeling, it's one of very important tools and techniques at natural language processing, which is very, very helpful at AI. What is topic modeling? Let's think about if we see an article about like World War II. This article, it might contain mixing types or mixed of types of topics in it. It might talk about history, about wars, about economy, about social life, about human, about everything. It might talk about psychology, sociology, and so on. So we need to analyze this topic to know what exactly, which topics it's talk about. How about if it's not only one topic? How about if it's like thousands of topics about something? If we scribed, for example, speeches of one politician, and we found that majority of topics he talk or she talk about it, it might be tended to be about economy, or about psychology, or about sociology. So you can think about how exactly he thinks or she thinks, and so on. So topic modeling, it's like clustering the text. So we know exactly what topics this text could talk about. Topic modeling, it's a major application of clustering. And we know that clustering at AI, it's grouping a huge amount of items into a homogeneous groups here, here, and here. A major application of clustering, where text is classified into homogeneous groups. Of course, the word classified here, it shouldn't disturb us about the word classification, which is at AI, because this is not classification, because this is unsupervised clustering. And to classify it into homogeneous group. So each group contains a specific topics which have together a common feature, containing similar features. A topic model is a type of statistical model for discovering abstract topics that occur in collection of text documents. So, topic modeling application, actually it applied at a big number of applications. It used at weight analysis, at news clustering, email processing, at everything. So we can, if we have a huge amount of topics, if we have a book, if we have news about from Times, Guardian, or something, we can know exactly what topics it talk about. All topic models are based on same basic assumption. Actually, it depends on a specific two basics, which is first, each document consists of a distribution over topics. If we have a document, this document, it might be an article, it might be a book, it might be a news. So it contains a distribution over topics. So maybe a one document contains 3 topics, maybe 1 topic, maybe 5 topics. And in the same time, each topic consists of distribution over words. A topic which talk about economy, it might use words like inflation, price, cheap, expensive, and so on. But a word which talk about history, it might contain words like king, queen, country, and so on. So the model is able to analyze everything, to know how many and which topics contain this document. And in the same time, each topic contains which words exactly. So topic modeling, there are several techniques of topic modeling, but we will pick 2 main techniques about it, which is latent directly allocation and gives sampling direct multinomial mixtures. How about LDA, latent direct allocation? It's just proposed by J.K. Pritchard and M. Stephens and P. Donnelly at 2000. LDA, it's based on a statistical model, a statistical distribution. It's based on what's called direct probability distribution in Bayesian statistics. Each topic represents a set of words. So LDA tool, because direct distribution, it's a very important theory, statistical or statistics. So applying LDA, it depends on how to use this distribution to find similar words at some topics so they can group them together. LDA depends on two steps. First, the words that belong to a document that we already know. So we might know that this word, which is the word queen or king, is related to a specific topic. And at the same time, the words that belong on a topic or the probability of words belonging into a topic. So if we have a specific article, which contains some words, so we can know that, yes, this article contains this topic, and this topic, depend on which words exist. So probability to be calculated. LDA is calculating two things exactly. Probability of T, known of D, which is proportions of words in document D which are related to topic D, and probability of W related to T, which is proportions of assignments of topics T over all documents that comes from word T. So by calculating these two probabilities, we will be able to exactly grouping all documents into some homogeneous groups. And by applying LDA, we use this library, which is called PyLDA-Viz. It's a Python library, and we use some tweets. I think, yes, this is tweets from Twitter. By applying it, it brings us these two homogeneous groups, this group and this one. And if we check this group, first, these two circles, the size of circle represents how many tweets exist at each cluster. So we can see that, yes, these two circles, they are approximately equal each other, but maybe circle one is a little bigger than circle two. And by checking these words, I don't know if it's clear or not, but by checking these words, which is most repeated words, we can see that group 2 or cluster 2 contain each of these words with this amount of repetition. While if we check it here, we can see that other words exist with another number of repetition. So if we check these data, we can see that, yes, maybe cluster 1 of this data and contains some words like here, sorry, get, broadband, please, service, need, and so on. So they may talk about specific topic exactly. While if we check it, we will find other words which exist with other number of repetition. By checking these two graphs, we will have more insight about which topic exactly exists here and here. How about the other tool for topic modeling, which is GSDMM? GSDMM, it's more modern than LDA. LDA, it's proposed at 2000, while GSDMM, it proposed at 2014. So it just came to correct and to fix some issues which LDA was not able to do it. GSDMM idea is finding a homogeneous group. So each group contains topic with similar features. Actually, GSDMM, it depends on how the topic can go to a group which is related to it. So those two persons, JN and J1, who invented it, who created GSDMM, they thought about if we have several or big amount of students, and we need to group these students to some tables. And each table, they will contain only students who have together a common interest in some movies or some things. So maybe some students, they are just interested at action movies or romantic movies or history movies and so on. So first, it's like we will ask the first student, which type of movies you like? So he or she, they will mention some types of movies So they will go to specific table. How about asking secondary student, what he or she, what types of movies he or she think or like? So they will go to another table. They might be this same table or another table and so on. And by asking each student about their interested movies, so some students, they will group together at some table, and maybe few students together, they will be at one table, or maybe one student, he will be alone at one table. It means that GSDMM, it's like checking each tweet, whether it contains some interests with other tweets and so on, by checking feature or common features at once. GSDMM, it got two main parameters, which is alpha and beta. Alpha and beta will lead to different clusters with different homogeneity in them. How? Bigger alpha, it will lead to more strict clustering. It means what? Where model tends to have more clusters with sharp selective conditions. It means that if we have 1,000 tweets, we might have several hundreds clusters because it will be very selective or very strict at clustering. So this model might not put two tweets together unless they have very, very close features together. While smaller alpha leads to more flexible model. And at the same time, bigger beta leads to less identical features at item in the same cluster. So if we have a less value of beta, it might put two tweets together while they are not very identical together. And at the same time, while zero value of beta will make all items the same cluster to have a common features. So if we make a quick compare about LDA and GSDMM, we can find that LDA, it's faster in running, while GSDMM is slower in running. LDA works well for long documents, while GSDMM works well for short documents such as tweets. And LDA doesn't need a huge resource of machine and well-developed implementation and software tools available. While GSDMM, since it's still a new technique, so only few basics implementations available so far. And the last challenge to us, and here when we applied GSDMM, we applied it indeed, and we found that we picked the alpha as 0.1 and beta as 0.3. So document number or number of tweets about the whole tweets, it's 129, 119, 133. And this value, it's 0.041. So if we check these three clusters, we can find that these words repeated with some numbers. So cluster one, the forward phone 200 times, number 180 times, line, and so. How about here and here? So by checking this analysis, we can see that yes, each cluster is just to talk about specific type or specific topics indeed here, here, and here. So the client who is working with this data right now, they are able to use or to treat each client who are related here, here, or here with specific conditions and so on. And here, by applying GSDMM with different values of alpha and beta, if we can see here, I'm sorry, the line, the font is very small, but if we can check here, alpha and beta, it's very here and here, so we can find that clusters, it's a change with their repetition words and so on. And now we have a question. What is the best values for alpha and beta? What is the optimized values for alpha and beta which can use? So we need to ask ourselves, how can we evaluate this clustering? If we have this clustering, how can we know that this clustering is the best? How can we know that, yes, these values of alpha and beta, we don't need to change it because this optimization is very good. So we need to evaluate this clustering. Actually, while working at GSDMM, we find no evaluation tool for it. It's still a new technique. We searched, we looked for everywhere. Is there any evaluation technique? And we found nothing. So we made and we did an evaluation tool for it using this. So evaluation, how can we evaluate it? How can we find exactly whether this clustering is better or there's another type of clustering is better? So we depend on word embedding to check two different things. What's called within clustering variance and between clustering variance depend on this equation. So we created this cost function, which depend on within clustering variance and between clustering variance. Within clustering variance, it should be minimized because as a same cluster, all words together, it should they should all talk about specific topic. While between clustering variance, they should be very far from each other. So if we make this cost function, which is here is A, which is a parameter, multiplied by within clustering variance, minus B multiplied by between clustering variance. Of course, this value should be minimized and this value should be maximized. This is why we put minus. And then we created this mathematical equation, which depend on the difference between each word and other words here and there and so on. This difference, it will depend on what's called word embedding. Word embedding, which means all vectors inside each word, which will use the by or which will depend on the library called fast text. Library fast text, it just can dig inside the word and get each vector or all vectors inside it and so on. So by applying this cost function, we found that here's the Python code, which I wrote it for this cost function, and we can find that by applying it, we found for this cluster, we find that between cluster variance is 0.008, within cluster variance 0.1, and we can get the cost function of course. So far, we're still looking for the optimization tool. How can we use it, which will be at next step? How can we use this cost function to reduce and minimize the cost function so we can get the optimized alpha and beta exactly and implementing GSDMM model to BT data and so on. Thank you so much. Welcome for any question. Here is reference and here is appendix for any information.
Right, so for the last bit, for your minimization or extremization procedure, you need a metric on the space of word spaces, so a distance. So how is the distance defined between? If I give you two words, what's the distance between them?
Yeah, it depends on, or it will be used by a library called fast text. Fast text, it uses what's called word embedding. Word embedding, it just dig inside the word and know the difference between it and transfer. And there is a specific test which is used for any word embedding library, which is the difference between house, horse, and apartment. Why these two words? Why these three words? Because house and horse, they are very similar at letters, but they are very far at meaning. And house and apartment, they are very far at letters, but they are very close at meaning. So any smart word embedding tool, it should bring the similarity between house and apartment more than house and horse. And using fast text library, which I used it brings it indeed. I checked it indeed, I have the code, which brings the difference or the similarity between house and apartment more than similarity between house and horse. It's like checking whether this tool is smart or not. This is why this word embedding, it cannot be applied to other languages. For example, if we apply it to French, Spanish, it will not work unless it's trained to it indeed.
So are you saying you've got basically a repository of those distances?
Exactly.
A database where these distances have been determined somehow and are stored.
That's right. That's right. And either there is another tool which is called the GLOVE, which is shortcut for global vectors, which is trained at Wikipedia. It trained at hundreds of millions of topics, and it can exactly bring what are the similar words. So even I read a code which is like have a huge topic, and I bring a word like London, and it asks the whole topic what are the most similar words to London. So it can bring words like Birmingham, Manchester. It's more close to London than other words like sea or ocean and so on.
Thank you. Just couple of questions. I mean, this last slide here where you've got the within and the between clustering, which is a very sensible idea, but I don't think that's a new idea, is it? That goes back to Fisher, I guess, in the analysis of variance or something, but I think that's a sensible way of doing it. My real question is, you talked about these Dirichlet distributions,
Yeah.
but where are you using that? What are you modeling as a Dirichlet distribution? Where does it come into?
Okay, Dirichlet distribution, it used exactly inside the equation of LDA, because LDA here, LDA model, it's built on Dirichlet allocation exactly. It's built about the, or it depends on the idea that all words are distributed in some way. So this model just pick what's the similar words to this. So if we have a specific word, how it's distributed with other words, so they can go back together.
Could you go back to where you had the conditional distribution? Oh, there, it's on this side.
So if I may add, these are those two probabilities are assumed to come from.
So those probabilities are modeled as Dirichlet.
Yes.
Right. Okay. So that's where the Dirichlet comes from. Okay. I think it's worth saying that something maybe. But the last question is that things change over time. I guess people's opinion of a political party or community changes. So can you build in a time dimension to these?
Yeah, of course.
Models?
Once we apply it, or once we build a specific topic, it can be applied over time series. Because if we build it, for example, right now for July 2020, and it brings specific results, so we can make it repeated. Because data scraping tools, even we have data scraping tools which can scrape each data upon specific time periods. So we can reapply it, and we might bring maybe close results or far results, which it depend on different and data exactly.
Because I think that would be a very nice extension to show how those clusters change as time moves on.
Yes.
I think there is a question from Ingrid.
Yeah.
I don't know, Ingrid, if you want to say it or write it. Whatever.
Hi.
Hi.
You can hear me. Thank
Yeah, we
you.
have.
Thank you, Hassan, for the
Yeah.
nice talk. I just have a question. You may have already covered it, but I don't recall. In your cost function, can you explain to me how you have defined the distance between words? What metrics you use to define the distance?
It's not mentioned here, the meters, but here, the difference here between WI and WJ, where WI was a specific word which we measure, and WJ other words. And since this is within cluster variance, so this word and these are all words inside the same cluster. While here, between cluster, so this word and this word, which is word at other clusters. So how about the difference between them? Actually, it depends on the idea of word embedding. So word embedding, it means what? If we have a word, it contains a fast text library, which I use, it contains 300 vectors. These vectors, it depends on the idea that it's like asking a question about this word. So for example, if we have a word lion, so we have a question. Is it alive? Yes. Is it something to eat? No. It is something precious, so non-available, and so on. This is what's called word embedding. So if we have any word, it's like asking a question about it, and we have 300 questions, and we have 300 values, maybe 1, maybe 0, and maybe a number between 1 and 0. So if we have another word which is very close to life, which is like something like tiger, we might find that almost all questions about lion and tiger, they have a very close answers together. But if we have a very far word from lion, which is like ocean, so we might find that all answers of 300 vectors or 300 questions is very far. And this is how fast text or any word embedding tool, how can they find the most close word to lion? It can detect that tiger, it's very near or very close to it than ocean and so on. So by using this difference, which is just subtracting 300 vectors for this word and 300 vectors for this word. So if we have two identical words or two words which is related to each other, as we said, house and apartment. So this difference, it will be very small value. So we knew that we need to minimize this. But if we have too far words from each other, like if I said house and horse, so subtracting these 300 vectors from each other, it will be a big one.